What's up, everybody, and welcome to this episode of Let's Make. This is the GameDev video series where I tend to just make up what I'm doing as I go along. And we are continuing our make of Flappy Bird. So this is how we have the game since last time. So I haven't done anything just yet. So we got the ball, or rather the bird, going up and down. I like the controls. We can go through, the tunnels are spawning. And we got the player to die. We have a score counter. So that's working quite nicely. Everything stops when the player is dead. So I think we're all good there. Now, what I did off camera was I made some models to replace our generic ball and cube as the tunnel. And so we've made a bird in Blender, and it has a very simple flapping animation. I didn't video this because I am awful at modeling and I'm very unfamiliar with the new version of Blender. So you would have just seen me cursing for about an hour. But that's our bird. I tried to make him as goofy as possible. And of course, we have a very simple tunnel. Now, I've imported these into the project. So they're here in objects. And so here's our bird and here's our tunnel. I've turned them into prefabs already, but I haven't added any of our functionality to it. So let's start with that. So if we go, here's our player here. Now, what I'm tempted to do is if we just take our bird prefab that I imported and I put it under the player as a child object, and then I come into the player and I'm just going to remove this mesh renderer. So we will go remove components and remove the mesh filter. Remove, and if all goes well, that should work exactly the same. Yep, and our little bird is flapping, perfect. Now we have the colliders on here, which is working out fine because the bird's about the same size and shape. But in reality, we probably should put the collider on the object. Actually, I'm not going to do that. I'm just going to adjust the collider so it fits the bird. And I feel like the bird's a little small. So let's come in and scale up our bird model. So we'll come here, grab our scale tool. And I'm just kind of looking in the play window as I'm doing this. There's no exact answer here. Let's try that. Or maybe a tad smaller. Let's go 0.5 all round. And we'll just adjust that collider a little bit. It's a little off center because the bird's a little off center. So maybe 0.1. And it seems to be hugging it quite nicely. I think I'll go with that. We'll be pretty generous with the space of the player. So we'll go with that. Have a quick play, see how that looks. Now, one thing this bird is not doing that the original game would do was the bird would rotate downwards. So this part, when the player wasn't pressing a button, it would not rotate that way. The bird would sort of crash to the ground like so. So perhaps we can animate that in using our player controller script. Okay, so here's our player controller script. I will zoom in this time because I think in the last videos this was hard to see. So we'll zoom in a lot. Okay, now we've got the update loop and we're testing to see whether the player is pushing the key down. So maybe in here we can do a kind of lerp situation on our bird. So we want the model to go from sort of 0 down to 60, not quite 90. Maybe 60. So there's probably a method in quaternions to do that, like a quaternion lerp. So, but the first thing we need to do is get a reference to our actual model. So we'll go private transform bird model. And we can get this in the start rather than setting it in the inspector, because it's just going to be the first child of this object. So we can get that simply by going transform dot get child, and it's going to be the first one. So we'll say get child at 0. Okay, so we've got our bird model referenced. Now, so we'll probably want to put an else in here. Okay, so in here, when we know the player is pushing down, what we'll do is we'll do a linear interpolation between 2 rotations, and we'll set that to be the bird model rotation. So the way we'll do that is go bird model is equal to quaternion. Sorry, no, that's not right. Bird model dot rotation. So the bird model is actually the transform. So we want to set the rotation. We're going to set it to a quaternion dot lerp. And what we'll actually do is pass in the current rotation as our starting point. So wherever the model is, the bird is rotated now, and when the player is pushing down, we want it to go back to a particular rotation. So we'll define a new rotation, calling quaternion.Euler. And we want it to go to 0. And if we jump back into Unity, we can see that the Y part of the rotation currently, so this is where we want it rotated when the player is pushing down. We can see it's about 108. And the Z in the rotation is about 0. So we can go 108 and then 0. And then wants to set a float T. And this is sort of capped between 0 and 1. And it's really how far between these two do we want to go. And I'm going to set it to 0.5. We'll go halfway. And essentially, every time the player is pushing down, it will rotate from its current position to halfway to where it's meant to be. And we'll see how that checks out. Of course, we want the opposite to happen when the player is not pushing down. So we will go if else, and we will put in, we'll copy that line down, and except this time we want to go from the current rotation, and this time we want to go to about 60 instead. And while we're here, we can fix the problem that we have that when the player dies, the bird slowly falls. And that's because if the player is alive, we just stop calling this extra gravity here. So what I could do is, since we're applying that every frame, we could cut that and put that above this line. And that should keep the bird falling at a better rate when the player dies. But let's give that a go. Let's see how that looks. Oh, that happened almost instantly. And it's not really flipping back. Okay, that's a shame. That's not quite what we wanted. Okay, so what's happening is this line here is only getting called occasionally, like once every 30 to 60 frames. So it's just not lasting, it's not being called often enough to have an impact on the rotation, where this is getting called every single frame. So I think another way to do this, what we might do is instead of calling it based on the input, we might do a little check inside fixed update. So we might call fixed update. And what we're going to do is we're going to call an if function, and we'll say if player RB, which is our rigid body, and we'll go velocity, and we'll look at just the Y component. If it's greater than 0, in other words, the player is moving upwards, we will copy this line from here. Else, if the player is falling, we will call this line. I think that'll be a much better way to do it though. So we can get rid of this else part here. We'll tidy that up. Save it out. Now let's give that a try. Let's see if that's any better. That's a lot better. So almost too quick. So let's go back and we'll set this to 0.1. May even need to take it down a decimal point. That's much better. So we can improve that probably slightly. So we're just going to adjust this. I think we'll adjust the one where it's rotating back up to be faster. So we'll turn that to 0.5. Okay, I think that's greatly improved. So we'll test that one more time. So much better. We'll leave that for now. It could use a little bit of fine tuning. Now, if we go back to Rider, Rider's telling me that this is not the most efficient way to do this. And so I'll convert to a question expression. So, oh, I don't like that it did that. That's a very long line. So I might just break this up a little bit. So basically this new notation, if you haven't seen it before, we're going to set the rotation as before. And we're going to query whether the player RB is greater than 0. And this question mark basically means that if it's true, call this line of code. If it's false, perform this line of code. So it's just a different way of writing the if function. And with that, I'm pretty happy with the bird. I think our player could be updated here. So we'll update the prefab. And then finally, we want to add in our tunnels. So if we go to our tunnel prefab that we currently have, it has all this stuff on it. So let us drag into the scene our new tunnel. And we'll also drag in our old tunnel. And so with the new tunnel, I'm just going to add a mesh collider. And I will copy from the old tunnel these scripts here. So we'll go copy component, paste as new, do that for the other one, copy component. And of course, we want to change the tag and the physics model. So we'll go tunnel, and hang on, did this have a rigid body? It did not have a rigid body. So we will go to our material here. I don't think we need this really, but we'll go no friction. And I think that is everything. So we can get rid of the old tunnel. And if we hit apply all, and we go now to our tunnel pool, we can swap out the model. And if that all goes well, it should just spawn in. Oh, it spawned on top of each other. Interesting. So what I'm going to do is I'm just going to turn off the player for a moment. And let's just watch that spawn system. Fascinating. Okay, our tunnel system is broken, the spawning system, and it probably has a lot to do with probably where the center of the object is, perhaps. Certainly doesn't want to rotate. Let's have a look at our tunnel spawner script. So we'll come here and we'll just have a look at how are we rotating. Oh, we're not rotating the tunnel, so that makes a lot of sense. Because before we were just using a cube, we didn't really notice that one was not turned the other way. Okay, so what I'm thinking is we're going to scratch the way we're spawning these tunnels. This is not an efficient way to do it. In fact, let's combine 2 tunnels into a single object that we can use. So we'll put it there. And of course, our spawn point is there. And what I'll do is I will duplicate that object, but naturally rotate it upside down. So it's positive 90 instead. And we'll lift that up until we get about the gap that we want. Let's say about 32-ish. And I'll create an empty game object that will hold both of them. Tunnels combined. And we'll drag and drop both those tunnels into this game object. So now when I move this single game object up and down, you can see I can set the tunnel height very differently. And then while we're at it, we may as well add in our score trigger into the center of that. So that way we don't have to have a score trigger spawner either. So this is a far more efficient way of doing it, and we'll drag and drop our combined tunnels as a prefab. And we will drop that into our tunnel pool. Now we'll have to think about the way it's despawning in a moment, but for now we will go with that. And let's go to our tunnel spawner. And so we want our gap position probably to be about the same. So we want our tunnels to sort of anywhere be from 14 down to -5. So let's have a look at our tunnel spawner. Spawn gap range, -5, and we'll drop that down to 14. Gap size, we won't need to worry about that because what we'll do is we'll come into our spawner script and we don't need 2 tunnels. In fact, we'll just go var tunnel, or we'll go plural, we'll say tunnels, tunnel pool dot get from pool. We can delete these now because we don't need references to those. We still want to set our gap position the same way, except this time when we spawn our tunnel, we just need to go tunnels.transform.position is equal to a new vector 3, and the x position hasn't changed. And this time we just want the gap position. We don't need to do, Z position. We don't need to do any of this sort of transformation of scale anymore because we're no longer working with that kind of object. So our code just got a lot simpler. And we can clean that up. And of course, we don't need gap size anymore because we'll define that based on in the prefab of the object. And we don't need a score trigger pool either. And with that, we will jump back here. And so I'll turn that off. We don't need a trigger pool. And we don't need, we do still want our tunnel collector, which has now lost a reference to the pool. So tunnel pool is all set up. Tunnel collector is set up, and our spawner should hopefully work. So let's hit play. We won't put the player back in yet. We'll just see whether or not those tunnels are actually going to spawn in as we thought they would. Indeed they are. I would say they're a little close together, and their offset is a bit strange. Let's move their Z position to, well, let's grab one of them. No, that's not one of them. The Z position we want to be about, is it 12? Nope. 11? No. 10. No, about 13. Okay, so let's change that to our tunnel spawner. We want the Z position to be 13 now. And how is it going to despawn? Let's look at our tunnel collector. So unfortunately, this is probably not going to work because it's going to hit the tunnel. But what we probably don't want to do is return that game object because we want the parent game object. So what we'll do is we'll go other. So that would be one of the tunnels. Oh, and this is going to get called twice as well. So what we can do, we could add a collider that would encapsulate both of these. So we'll go just a box collider, and we will set the width to be about 4. And we'll go the Y to be about 50 and the Z, let's go 30. Now, because this is just for the sake of being deleted, we don't have to worry too much about it being accurate representation of the objects, but we do need to make sure this is a trigger, and we will create the tunnel, we tag it with tunnel. And we will come in here and we'll just untag these inner tunnels, because otherwise they will trigger the collector twice. And of course we will sable that as a prefab. We'll turn that off and let's hit it play, and we're looking to see that it gets deleted. Well, that's unfortunate. Okay, and here's our problem. Here is our tunnel, and here's the collider, because the object is actually back here because the object's not moving. The children in the object are moving, which is a silly mistake. So we'll put that back on, and we'll have a look at what is the tunnel controller, is the script we need to add to here. Not collector, that would be incorrect, but tunnel controller. And we're using a speed of 5, that sounds fine. And we'll go into here and we will just remove this component. And we actually remove the collision trigger, can't we? No, we want to keep the collision trigger because that's dealing with the player, so that's perfect. But we will get rid of the tunnel controller. We don't want that to move. We want the parent object to move. So we'll apply that. And it will work perfectly this time. Of course, I got to get rid of the tunnel controller on the score trigger as well. Okay, cue the perfect playback. Interesting. Clearly, I did something weird. Oh, I thought I deleted that. Let's try that again. Okay, this time they're all moving in sync, so in theory, when they hit the tunnel collector over here, they will automatically get sent back to the pool. Success. All right. So that's working perfectly. Let's put on our player and have a go. I'm guessing if I go tunnel spawner, I feel like the spawn rate's a little fast. So let's slow it down a little bit. Turn on the player. And just like that, it is working smoothly. Maybe I was wrong. Maybe it's, oops, I'm dead. Maybe it's not that big of a gap. But either way, we've got our new models in place, which is fantastic. Okay, so I think the next big challenge that we want to tackle is saving our high score and being able to load it when the game loads. So to do that, we're going to need a save system. So we'll open up another script and we'll call it save system. And this is not going to be a mono behavior, and it will be, in fact, a static class. And we don't need start or update. What we do need is a public static method that returns void, and it will be to save score. And we'll just take in an integer, and we'll call it high score. And then we'll also need another method which we'll make static. So it's public static void load score. Now it's not a void actually. It's going to return an int. Now, there are plenty of tutorials on the internet about how to do this, but essentially what we'll be doing is saving the data as a binary file into a permanent folder that Unity keeps track of. So we need call a using statement here, and we'll go using system.runtime.serialization.formatters.binary. Is that what it is? Formatters.binary. I think that's what we need. Okay, in our save score system, this will be pretty easy. First, we need to declare a binary formatter. So we'll go formatter equals new binary formatter. And now we need to also define the path, and that's not how you spell formatter. We need to define a path. Now, there's a special path you can use that Unity keeps track of. So we'll go application.persistent.dataPath. So this is somewhere on the computer. It's usually, like if you're on a Windows, it's under users.application.data or something like that. And then we just need to pass in, we need to give it a name. So we will call it, in that folder, we'll go Flappy bird save or something. You can call it whatever you want, and you can give it any file extension you want because it really doesn't care. And then we need a file stream which uses the using statement system.io. So Writer automatically added that for me. In fact, we'll go bar, we'll go stream. Is equal to new file stream. And this is where we want to pass in our path that we just created. And the file mode that we're going to use is called create. And because we're really only interested in saving one particular piece of data, we can just pass in that data. But if you wanted to encapsulate more, instead of passing in an int, you could pass in a particular class. There are some constraints about what data you can serialize into a binary format, but an integer will be more than fine. So we'll go format.serialize, and we'll pass in the file stream, and we'll pass in high score. And of course, we'll have to close the stream. Otherwise, you can get some memory leaks there. And that's all we need to save the score. To load the score, we sort of want to do this all again, but in reverse. So we'll define a new formatter. I'm just going to copy that. And the path we can also copy. And the stream, we also want the stream, but we do need to change it from file mode to open. And then we simply go if path, oh, hang on. Is it file? If file.exist. Yeah, so we need to check that the file exists. So, and we'll pass in the path. If that returns true, actually, we can then define our stream in there. That way, there's no point creating a stream if there's no object to create it. And that goes for the formatter as well, now that I think about it. So we can just have the path defined, and then if there is a file with that path, then we can define a formatter, we can define a stream. Okay, then we can directly return our high score. So we can go return formatter dot deserialize stream, and what we're going to need to do is make sure it's an int. So at the front here, we will just cast it as an int. Actually, we can't do that. The problem with that is now we need to close the stream and we've already returned from the function. So actually what we'll need to do is define it as a variable. So we'll go var high score is equal to formatter.deserialize the stream, and we'll cast it as an int. We will then go stream.close before returning the high score. Now we'll go else. Now, if the path doesn't exist, that means the player hasn't played before, or maybe they've deleted the data. In either case, what we will simply do is return 0, because that will be their high score. They don't have to do very much to beat it. And that's all we need for our save system. Now we just need to implement this. So if we then go to our game manager, so our game manager will store our high score. So we'll go private int score. We'll also go private int high score. And we'll just set to 0 by default. And in awake, we will use our save system. So we will go high score is equal to save system. So we'll call it as a class, save system dot, because it's static, we can then just call load score. Now, in terms of saving the score, what we want to do that is perhaps do it on the player's death. So the game manager already has an event being called on player death. So what we can do is just create a private method and subscribe to that event. So we can go private void on player death. Now it's going to get upset with me because we defined the Unity event in here. So we'll just go on player death event. And so on player death, what we want to do is save the high score. So we want to go if the current score is greater than high score, which we loaded at awake, then what we want to do is call our save system dot save score, and we'll pass in our score. And that's not going to get called by itself. So after we load the high score, we will go on player death, so the Unity event, and we will go add listener, and we will add on player death event. Now, someone may realize in at least the last part, when we created this event system, we're not really unsubscribing to these events at any point, which could create memory problems if we delete any of these game objects. But since we're not going to be deleting any of these game objects, we don't really have to worry about it. We'll just be reloading the scene when the player dies. And I think that will do nicely. Okay, with that in place, what we now need to do is implement some UI to appear when the player dies, with showing the high score and maybe like a button to reset. So let us go to our UI canvas. And what we'll do, we'll actually add, under the canvas, we'll add an empty. And we'll get the empty to fill up the canvas. And what this will do is this will be a end screen holder. And under that, we will then create, we'll create like an image to hold the background. So let us make that a lot wider. Something like that, 750. We might actually make it in the center and we'll stretch it out all the way and then we'll pad it maybe by 200 each side. And we'll just set the color to something sort of a bit boring and maybe slightly transparent. Let's go with that for now. And we also want, under the background, so as a child of the background, we also want a text field, and we will call it score. And we'll put that up and we'll align that near the top. We'll give it some padding from the top, maybe -100. We'll expand it out a bit, making sure to center it. And we'll just set that to 0 for the moment. And we'll actually duplicate that. And we'll set one to be highscore, except this time we'll sort of center it in the middle, like so. And as a child of those objects, we'll create another text field. And the reason I'm doing all these child objects is just so it makes it easier to align things. So I can align this all the way in the center. And we'll make sure that is centered, and we will say score. And now I'll just position it up by, say, 80. Go auto size, and we'll set the width maybe all the way. So we'll just adjust some of these settings. Maybe -200 for the score. And maybe 150 for the text. So go score, text. This isn't necessarily the best way you would go about aligning UI, because you can get some screen issues if we sort of adjust the screen size. So maybe not the best way to scale and position things, but it will work for our purposes. So highscore, text, and position that one probably about 150 over. What did we put the other one at? 150. This one somehow seems further away. Well, actually, we'll go to this other one, and we'll just copy the component just so all the formatting's the same. And of course, we'll just change back to highscore. We need to increase the width. Okay, so we got our score and our high score in position. We'll also, while we're here, we'll add a restart button. So we'll go UI, button with Text Mesh Pro, and we'll just put that towards the bottom. In fact, we'll position it. Oh, that's way too far at the bottom. That's because we wanted to put it as a child of our background. So let's put it as a child of the background and try that again. And then we'll position it up. So let's go 100. Give it a bit of padding from the bottom. And we'll make this much, much bigger. And we'll make that text auto size to the whole. And to the whole button, and we will call it restart. And we'll give our button a bit of a color here. And I think we don't really have a lot of choices in terms of like an image to make this look nicer. I don't really like that red. Let's go with like an orange, more orange color. And we'll make our text white like everything else. Make it bold, and we will change the font. And what I'll do is also make it all capitals. And that will do for an end screen. In the original Flappy Bird, it has like an option to share to a leaderboard. We're not going to worry about that because that's a little more. Oh, we'll cut that last bit. Okay, I think that'll do for our end screen. We won't add a. Fuck. Okay, I think that will suffice for now for our end screen. We won't add... Cut, sorry. Okay, I think that will do nicely for our end screen. Now, in the original Flappy Bird, there's another button to sort of add to a leaderboard. We're not going to worry about that because we're not going to go ahead and set up a leaderboard for this game, but the process for adding another button will be essentially the same for the functionality we add to this one. And so with that, we are ready to actually encode this to do something useful. But to do that, we're going to need a way to control these variables. And the way I'm going to do that is create a C# script, and we're going to call it UI Manager. And what we could make this a singleton as well, but no, we won't worry about that. No, we don't need to worry about that, in fact, because we created our scoring as an event. So all we need to do is we need to create some references to the end screen. So we'll go game object called end screen. And what we're going to use that for is to hide the canvas, or that part of the canvas anyway. We also need a reference to the text field. So we'll go serialized field private text mesh pro UGI, and we'll go score text, and we'll duplicate that, and we'll create a high score text. And then we need to respond to a couple of different events. Actually, we only need to respond to, because we're already taking care of the score text, aren't we? Wait, do I already have a UI manager? No. Oh, we already have a UI controller. I forgot about this. That's controlling this score. So let's open up the UI controller. How are we doing? Okay, so what I might do, we're going to copy this into our, because I sort of duplicated our scripts here, and we'll copy it into UI Manager. Get rid of that double reference. And so, yeah, in start, we will add a listener and we'll set the score change. Now, we also need another event on player death. Which I don't think takes any input. And basically what we'll do on player death is we will set the end screen to active. So we'll disable it by default. But before we do that part, we need to set the high score. So we will go I'm just wondering whether this will call race condition. So what we'll do is we'll say the high score okay, so in order to do that, we need to quickly jump back to our game manager and we need a public way of accessing the high score. So we need a public way of getting the score. So we'll just make a public int called score, and basically it will just point to the private method for score. And so in our UI manager, when we go to on the player death and we go to show the screen, we want to set the high score text to be equal to the score. So high score text is equal to game manager instance score to string. So that will set our high score text. No, it won't, will it? Let's get rid of that. Get rid of that. Okay, we have a bit of a race condition here. The high score doesn't get defined until this on player death event is called. So if we go to game manager, we can see on player death event is when we save the new high score. So here's what I'm going to do. I'm going to create, we need a way to get the high score. So we're going to create a public get method for the high score. However, it won't just be high score. So we need a proper get method. And basically what we'll do is we'll go if score is greater than high score, we will return score. Else we will return high score. And as a matter of fact, we can then just come in here. We could come in here and just save the score every time. No, we'll leave that as it is because we don't want to save if we don't have to save the data. But we can come back to our UI manager now, and I'll zoom in here, trying to remember to do that. And on player death, what we will do is go high score text is equal to GameManager.instance.highscore toString. So it will always return either the saved high score or the current score if it's greater. And we'll do that in the player def. We'll then set the end screen to be true. Of course, we do also need to set a new score text. So we actually need two of these because we need to go, we'll call it end score text. And we'll go end score text is equal to GameManager.instance. Actually, what we could just do is set it to score text, like so. And of course, we need to subscribe. So GameManager.instance.onPlayerDef.addListener on player def. So when the player dies, we will set the high score. We will set the end score text correctly, and then we will also set the end screen to be true. And what we'll also do is hide the previous score. So which one is that? We will go score text dot enabled is equal to false. So let's go set up those references in the inspector here. So first we got to add out, we'll get rid of UI controller because I sort of doubled up there, and we'll get UI manager. So our end screen is the end screen holder. Our score text is this one. And our end score text is here. No, it's not. That's the name. This is the actual score. So score, and then high score text should be that one. And then I will disable this by default. Okay, so we'll hit play, make sure that score counter is going, and then hopefully our high score comes in. So we'll go 1, oh, that didn't work. So we got 0, well, that part's accurate. So it popped up correctly. One, and our high score is 1. So let's just see if that high score gets saved. So to do that, I'm just going to die. The high score is not getting saved, unfortunately. So let's go have a look at that. Okay, that took a long time to figure out. Turns out we just had a slight typo in our path, and that these had these spaces in front of them. So we'll get rid of those. They may have also been different, but anyway, if we head back on into Unity and I hit play and I die, you can see the high score gets set to 2. So our high score is loading in. Let's see if I can break it. Oh, not very good. So it didn't change the high score. Let us just quickly come to our tunnels combined prefab, and I'm going to just increase them a lot just for a quick test, just so I can actually pass. And I still managed to lose. Holy crap. Oh, went way too high. Okay, 1, 2. Oh my goodness. I wonder if there's a bug here. It's definitely not getting the input right. There's something definitely wrong here. Okay, but the high score up increased. So there's definitely a bit of a lag in the input. So we'll have to deal with that momentarily. In the meantime, let's drop these back. But that is at least our saving system working, and we've got our new models in place. And we have our UI popping up. Now, the last thing we'll do today is get this restart button going. And to do that, we'll jump into our UI manager and we'll create a public event. Oh, sorry, rather a public method. We'll go public void and we'll go reset level. And what we'll actually do here is we will go scene manager dot load scene, and we will just pass in the build index of 0. And so when we come into our button, so if we go on our button, you can see on it there's a little event thing at the bottom. So if we hit plus, drag in our canvas that has our UI manager on it, and we should be able to select our public method we just created called reset level. And with that, we will end and we'll hit restart, and you can see we're straight back into it. Now, what you probably want to do is we'll set up like a little pause so the player doesn't just automatically restart straight away. So we'll do that next time. We still got a couple of things left to do. We want to change the start a little bit. I want to investigate this input lag a little bit. It's not quite feeling right. But with that, I think that's all we'll cover today. And so thanks for watching if you made it this far, and I will see you next time.